Hi there. I would like to go over a few videos in section 7.1. This is the section on integration by parts. The first problem that I want to look at is the integral that goes from 1 to 5 of natural log of x quantity squared divided by x cubed. So we are going to use integration by parts amongst others in this problem, and I'm going to start by choosing my u and my dv. So in this problem, I'm going to let u be equal to natural log of x quantity squared. And that means that my dv will be 1 over x cubed dx. Or if you want to write that rather as x to the power negative 3 dx, that might be helpful later. All right, so immediately it follows then, if u is equal to natural log of x quantity squared du by the chain rule, derivative of the outside will be 2 times, leave the inside alone, raised to the power 1. And then derivative of the inside, derivative of natural log of x is going to be 1 over x dx. Where v, again, if I find the integral of x to the power negative 3, this will be x to the power negative 2 over negative 2. Again, if you'd rather clean this up right here, we can write this as negative 1 over 2x squared. All right, so I'm going to plug this into our formula. The integral of u dv is equal to u times v minus the integral of v du. So this is going to be the natural log of x squared u times v minus 1 over 2x squared minus the integral of v minus 1 over 2x squared times du. And this is going to be 2 times natural log of x times 1 over x dx. So I definitely have quite a bit of cleaning up to do before I start evaluating this problem. So this will be, I can write it just if I make a simplification here, negative natural log of x quantity squared divided by 2x squared. And I'm just going to kind of gesture here. The minus and the minus here kind of is going to turn into a plus. And I'm also going to either cancel or factor out. You see the coefficient 2 cancels with the coefficient 2 in the bottom. And so what I'm left with then is going to be plus the integral of natural log of x divided by x cubed dx. All right, so this immediately leaves me with another integration by parts problem. So let's just take this component right here. I'll kind of draw a little box right here. Let's evaluate it over here. So the integral of the natural log of x, you can either say that it's divided by x cubed or 1 over x cubed. And let me make that a little more clear, x cubed dx. Again, we're following integration by parts, so I'm going to decide on my u. In this problem, u is natural log of x. Always, if you have a logarithmic component, that's always going to be your u. So u is equal to natural log of x. So that means dv is equal to 1 over x cubed dx, or if you will, x to the power negative 3 dx. So it follows then that du is equal to 1 over x dx, and v will be equal to x to the power negative 2 divided by negative 2, or again, negative 1 over 2x squared, if you want to go ahead and clean that up. All right, so I'm going to put this into our formula. Integral of u dv is equal to uv minus the integral of v du. So this is going to be u is natural log of x. V is negative 1 over 2x squared minus the integral of v, which is negative 1 over 2x squared, times du, which is 1 over x dx. All right, so again, let's clean up. This is going to be equal to negative natural log of x divided by 2x squared. Again, the minus and the minus is going to become plus, and I'm going to factor out the coefficient 1/2, right? All right, some further simplification. I have 1 over x squared and 1 over x. This is going to become 1 over x cubed dx. And of course, we can write this, if you'd rather, as 1/2 times the integral of x to the power of -3 dx, which means this integral is going to be equal to 1/2 times integral of x to the power -3, as before, x to the power -2 over -2. And so one last simplification here gives negative natural log of x over 2x squared, and this will be minus 1 over 4x squared. All right, so all of this can now go back. Let's zoom back out. All of this now goes back into my original problem. So for the original problem, we have minus natural log of x quantity squared over 2x squared plus this entire component, negative natural log of x over 2x squared minus 1 over 4x squared. And then I want to clean this up just a little bit more. So this is equal to minus natural log of x squared over 2x squared. And I'm just removing, you can really just remove the brackets. So minus natural log of x over 2x squared minus 1 over 4x squared. All right. The problem wanted me to evaluate from 1 to 5. So now we're going to plug in top minus plug in bottom. Here we go. So I will have minus the natural log of 5 quantity squared divided by 2 times, and I'm going to clean up as I go. So x squared, if we evaluate at 5, that becomes 25, minus natural log of 5 over 2 times, again, x squared. If we plug in 5, that's going to be 25 minus 1 over 4 times x squared. So 4 times 25. All right, so this is plug in top, minus, let's plug in the bottom. I will have minus natural log of, oops, it's not 0, natural log of 1 quantity squared over 2 times 1 minus the natural log of 1 over 2 times 1 minus 1 over 4 times 1. All right, so let's quickly take a closer look. What happens to each one of these? We know that the natural log of 1, let me make the natural log of 1 is equal to 0. So that means this term is going to be equal to 0, 0. So we're just left with really minus 1 over 4 here. And so final simplification here. I will have minus natural log of 5 squared divided by 50 minus natural log of 5 divided by 50 minus 1 over 100. And then minus, minus, so this will become plus 1 over 4. And then finally, my goal is to give my answer as an exact value. So minus 1 over 100 plus 1 over 4 is equal to plus 6 over 25. All right, I'm going to look at one more problem in this video. The next problem here, we have the integral from 0 to pi of e raised to the power cosine of t times 2 times sine of t, or 2 times sine of t times cosine of t dt. So I'm going to start this problem doing substitution. I anticipate I'm going to do substitution as well as integration by parts. So just to avoid using the variable u twice, instead of u substitution, let's just call it x substitution, or you can use any variable that you like, w substitution. So I'm going to start here. I'm going to call this, let's say step 1. Let's call it x substitution. All right. So what I'm going to do is I'm going to say that x is equal to cosine of t. If x is cosine of t, then dx is equal to minus sine of t dt. So if we had rearranged this equation, you're going to see we would have the integral of e to the cosine of t. I'm going to write this as times 2 cosine of t and then times sine of t dt. And I'm just rearranging it just so that you can see that I do have a sine t dt in my problem. So I just need to move this negative sign to the other side. So if we're going to come back here and do our substitutions, you will see that. So this is going to become x cosine of t is going to become x. And then the entire sine of t dt is going to become negative dx. All right, so when I make my substitution, I will get the integral of e to the x times 2x times minus dx. And so if we clean this up just a little bit more, we'll get negative 2 times the integral of x times e to the x dx. All right, so now we're down to a more manageable integral. And again, for this guy right here, I'm going to use integration by parts. So here we go. I'm going to say, all right, by integration by parts, I would like to let u be equal to x, and I'm going to let dv be equal to e to the x dx. That makes du equal to dx. This makes v equal to e to the x. And then our formula says the integral of u dv will become u times v minus the integral of v du. All right, so this is going to be equal to x times e to the x minus the integral of e to the x dx, which is just equal to x times e to the x minus e to the x. All right, so back to my original problem, this means that we now are looking at the integral of, let's see, negative 2 times x times e to the x minus e to the x. And we were asked to actually evaluate this integral from 0 to pi. So let's plug in top minus plug in bottom. I'm going to leave the negative 2 out here. If I plug in the top, oh, I forgot to do something very big. Let's back up just a little bit. I forgot a very, very big step. I am still under the steps of substitution. The first thing that I need to do is back substitute. So remember, we decided to let x be equal to cosine of t. So let's back substitute first. So this will be negative 2 times cosine of t times e to the cosine of t minus e to the cosine of t. And now we can evaluate from 0 to pi. You could either do that or you could convert your bounds. Either way is fine. All right, now plug in top minus plug in bottom. All right, if I plug in the top, I'm going to get cosine of pi times e raised to the power cosine of pi minus e to the power cosine of pi. Minus, plug in the bottom, we will have cosine of 0 times e to the power cosine of 0 minus e to the power cosine of 0. And again, just because I know students are forgetful, this might be helpful. If we draw a graph for cosine of x, So this is pi halves, here's pi, here's 3 pi halves, and then finally here is 2 pi. So that might help you spot those values a little bit faster. All right, so cosine evaluated at pi is equal to -1. So that means this whole value will be -1, -1, and -1. And then cosine evaluated at 0 is equal to +1, +1, and +1. All right, so this gives me the equation -2 times, I've got -1 times negative, let's see, e to the, I'll write it like this, e to the -1 minus e to the -1. All right. Let me actually minus over here, we've got 1 times e to the power 1 minus e to the power 1. All right. So I've got -1 times 1 over e minus 1 over e minus e minus e. All right, so again, you see that this is equal to 0. So I've got -2. All right, I've got -1 over e minus 1 over e. That gives -2 over e minus 0, of course. It's just going to be equal to 0. So I get my final answer here to be 4 over e.